Hello, everyone. Today we embark on a fascinating journey through time to unravel the rich tapestry of engineering history. From ancient wonders to cutting-edge innovations, this is the story of human ingenuity. It's the invisible hand that has guided the development of civilizations, from the earliest human settlements to the sprawling cities of today. Despite its seemingly invisible presence, its impact is undeniable. Indeed, engineering has been the silent force shaping our world since time immemorial. The dawn of engineering traces back to the ancient civilizations. Long before computers and complex machinery, the human mind was the ultimate tool. Take a moment to consider the Great Pyramids of Egypt, for instance. These monumental structures, built around 4,500 years ago, were not just impressive for their sheer size, but also for the precision with which they were constructed. Each block, weighing an average of 2.5 tons, had to be cut, transported, and fitted into place with an accuracy that still baffles experts today. Similarly, the Roman aqueducts stand as a testament to the innovative spirit of our ancestors. These waterways, some stretching several miles long, were constructed to carry fresh water into cities and towns. The Romans built these aqueducts with a slight, consistent gradient to ensure the water flowed in the right direction, showcasing their understanding of gravity and fluid dynamics. And let's not forget the Great Wall of China, a feat of engineering that extends over 13,000 miles and was built to protect the Chinese Empire from invasions. It highlights the ancient engineers' grasp of geography and their ability to design and execute large-scale projects over varied and challenging terrains. These remarkable structures not only highlight the ingenuity of ancient engineers, but also their understanding of the natural world. As we move into the Middle Ages and the Renaissance, engineering takes a more formal shape. During this period, the world began to see the development of complex machinery and architectural marvels that continue to astound us even today. The Middle Ages, also known as the medieval period, spanned from the 5th to the 15th century. It was a time of great innovation in the field of engineering, particularly in the realm of architecture. Gothic architecture, characterized by pointed arches, ribbed vaults, and flying buttresses, was born during this era. These techniques allowed for the construction of vast cathedrals with towering spires that reached towards the heavens. These awe-inspiring structures were not only feats of aesthetic beauty, but also marvels of engineering, demonstrating the ability of humans to manipulate their environment in increasingly complex ways. As the Middle Ages gave way to the Renaissance, engineering continued to evolve. The Renaissance, a period of cultural rebirth spanning the 14th to the 17th century, saw a renewed interest in the classical knowledge of the Greeks and Romans. This period brought about many advancements in various fields, including art, science, and of course, engineering. One of the most notable figures of this time was none other than Leonardo da Vinci. Although he is perhaps best known for his artistic masterpieces, da Vinci was also a brilliant engineer. His notebooks are filled with sketches of inventions far ahead of his time, including a flying machine, a tank, and even a robot. These designs, while not realized during his lifetime, were testaments to his genius and foresight, and they laid the groundwork for many of the technological advancements that would come centuries later. With the Renaissance, engineering began to be recognized as a distinct discipline, separate from art and science. The inventions and structures of this era demonstrated the power of human ingenuity and creativity, pushing the boundaries of what was thought possible. The Renaissance was a period of great innovation and progress, setting the stage for the scientific and industrial revolutions that would follow. With the Renaissance, the world witnessed the birth of modern engineering. The Industrial Revolution, a period of rapid industrial growth, changed the face of engineering forever. The impact of the Industrial Revolution on engineering was profound. This era, spanning from the late 18th to early 19th centuries, marked a departure from manual labor to mechanization, bringing about significant advancements in engineering. One of the most iconic inventions of this period was steam power. The steam engine, developed by engineers like James Watt, revolutionized transportation and industry. By converting heat into mechanical energy, Steam engines powered everything from factories to locomotives, driving the growth of industries and economies. This was a game changer, a shift from relying on inconsistent natural forces like wind or water to a reliable, controllable source of power. The evolution of railways was another significant outcome of this era. The genius of engineers like George Stephenson gave birth to the world's first public railway. Railways not only drastically reduced travel times, but also opened up trade and communication possibilities like never before. This invention stimulated urban growth, social change, and economic development. Simultaneously, manufacturing machinery underwent significant transformations. The introduction of automated machines like Richard Arkwright's water frame and Eli Whitney's cotton gin multiplied production rates exponentially. These machines, engineered to perfection, set the stage for mass production and the concept of assembly line, which we still use today. The Industrial Revolution also saw the evolution of engineering education. As industrial growth demanded more skilled engineers, formal education in engineering began to take shape. Schools and universities started offering specialized engineering courses, establishing the groundwork for the engineering disciplines we recognize today. The Industrial Revolution not only revolutionized engineering, but also laid the foundation for the modern world. With its inventions and advancements, it transformed societies, economies, and cultures. It redefined the role of engineers, from builders and craftsmen to innovators and problem solvers, shaping the world as we know it. In the 20th century and beyond, engineering has taken a quantum leap. As we stepped into the 20th century, the world of engineering was poised on the brink of a revolution. The first major breakthrough came with the development of computers. These machines, initially as large as rooms, were gradually miniaturized into desktops, laptops, and today, into the smartphones that fit into our pockets. They've become integral to our lives, powering everything from our communication systems to our entertainment and even our vehicles. The field of computer engineering has since branched out into numerous subfields, including software engineering, which has given birth to the digital world we inhabit today. From the apps we use to order food to the software that powers our cars, none of it would be possible without the tireless efforts of software engineers. Then, we took a giant leap, not just for engineering, but for mankind. Space exploration took off in the mid-20th century, with engineers playing a pivotal role in designing and building the rockets that would take us to the moon and beyond. Today, engineering feats like the Mars rover and the International Space Station stand as testaments to our ability to push the boundaries of what's possible. And it's not just the vastness of space that engineers have conquered. At the other end of the scale, we have nanotechnology. Engineers are now able to manipulate material at the atomic and molecular scale, creating microscopic machines and devices that could revolutionize fields as diverse as medicine, energy, and manufacturing. Each of these advancements has had a profound impact on our daily lives. Computers have revolutionized the way we work, learn, and communicate. Space exploration has broadened our horizons and deepened our understanding of the universe. Nanotechnology, though still in its early stages, holds promise for breakthroughs in numerous fields, from healthcare to environmental protection. From exploring distant planets to creating microscopic machines, engineering continues to push the boundaries of human imagination. So, what lies ahead in the future of engineering? In the vast expanse of possibilities, the future of engineering looks to be as dynamic and transformative as its past. The pace at which technology is advancing means the engineering landscape is changing faster than ever. Let's dive into a few areas where engineering could really shake things up. First, let's talk about artificial intelligence. It's no longer just the stuff of science fiction. AI is here, and it's changing how we engineer. From designing smarter systems to automating complex tasks, AI is poised to revolutionize the field. But it doesn't stop there. As AI continues to learn and evolve, it could potentially tackle more complex engineering problems or even create new engineering disciplines altogether. Next, we have quantum computing. This field is still in its infancy, but the potential is staggering. Quantum computers could perform calculations far beyond the capabilities of any current computer. This could lead to breakthroughs in everything from material science to climate modeling. Quantum computing could redefine the very fundamentals of engineering, opening up a whole new world of possibilities. And let's not forget about sustainable technologies. As the world grapples with climate change, the demand for greener, more sustainable solutions is growing. Engineers will play a crucial role in developing these technologies. From renewable energy sources to eco-friendly materials, sustainability is set to become a key focus in the future of engineering. These are just a few glimpses into the future. There's so much more out there, waiting to be discovered, waiting to be engineered. As we push the boundaries of what's possible, we'll continue to shape our world in ways we can't even imagine yet. As we stand on the brink of yet another revolution in engineering, one can only wonder, what's next? Thanks for watching until the end.